Assalamualaikum warahmatullahi wabarakatuh. My name is Yonathan Iwangsa Sima or Iwang with last number of my NRP is 168. And now I will explain and also answering the question about the Otto and diesel engine. First of all, I will explain what an Otto and what a diesel engine is. The diesel engine was invented by Rudolf Diesel, where this engine carries out the combustion process using injected fuel and use compressed air that has high temperature. And the Otto engine or gasoline engine was invented by Nicholas Otto, where this engine used spark plugs to help combustion occur. And now let's discuss how it works. In diesel engines, we don't need to mix air and fuel. The fuel injection has been designed by itself, and for the hot air, it is compressed by a piston that moves up or toward the top dead center position, so that where the self-ignition is. The fuel is also not recommended to have high volatility. In diesel engine, combustion can be anywhere and out of control, therefore more noisy and not smooth. To reduce it, we can multiply the number of cylinder, like 4-stroke or 4-cylinder maybe. For the Otto engines, use gasoline as the main fuel and mix it with air, where this fuel must have high volatility or the ability to evaporate quickly, and when conducting fires must be assisted using a valve. For the Otto engines, use gasoline as the main fuel and mix it with air, where this fuel must have high volatility or the ability to evaporate quickly, and when conducting fire must be assisted using a spark plug, because this machine does not have high compressed air pressure and compressed air temperature. On the Otto engine, quiet operation due to the mixing of air premix during smooth fuel combustion. From the explanation above, it can be concluded the difference between the Otto and diesel engines are from the spark plug, self-ignition process, and the fuel. And then we must have heard a lot of 2-stroke and 4-stroke, and what is it and what the difference between them. For the 2-stroke, in general, when the motor engine is working, but of 2-stroke and 4-stroke for process still occur, that are suction or intake, compression, explosive or power, and for the last is exhaust in one combustion cycle. In a 2-stroke engine, all four processes can occur in one turn of the crankshaft or axle, clutch stage or crankshaft. In one such turn, the piston moves twice up and then down. When the compared to 4-stroke motor, 2-stroke motor usually have more power even though the engine capacity is the same. And for the 4-stroke, meanwhile in 4-stroke engine, one combustion cycle occurs in 2 revolutions of the crankshaft. As a result, this type of engine is less responsive, but the fuel combustion that occur will be more efficient. This type of engine is seen as more environmentally friendly because it only processes the combustion of gasoline, no side oil is burned, and this engine outputs relatively less power at each engine rev than the 2-stroke. And in 4-stroke motors, the process of intake, compression, work, and exhaust process usually always stand alone, so that the performance of the motor engine will be more precise, efficient, and stable. Because of the pressure is smaller than the 2-stroke engine, the use of fuel is more efficient. And now the innovation related to diesel engine that Rudolf Diesel has done include: first, in 1900, the first diesel engine factory in London was inaugurated. And for the second, in 1905, diesel engine began to be used as a train engine. And for the third, pick the 1910, when he appeared the Paris Fair with the design of the diesel engine powered by peanut oil and marijuana oil. And 2 years later, when giving a speech accepting this patent for this new engine, Dinia recorded his most historic statement about the future of engine running on vegetable oil fuel, which are now known as biodiesel. Using vegetable oil as a fuel for now seems meaningless, but in time it will become important later as petroleum and coal-fired products are today. The biodiesel engine was further refined by Louis L. Speed. Now I'll explain you about the Otto and diesel cycle. For the Otto cycle, for the first is the mixture of air and gasoline vapor in the cylinder is compressed adiabatically when the piston moves up or compression stroke. Because it is pressed adiabatically, the temperature and pressure of the mixture increase. At the same time, the spark plug sparks so that the air and gasoline vapor mixture ignites. When burned, the temperature and pressure of the gas increases. The high temperature and high pressure gas expand against the piston and push the piston down or power stroke. For the third, the burning gas is then discharged through the exhaust valve and flowed into the exhaust pipe or exhaust stroke. The intake valve opens again. The mixture of air and gasoline vapor flows from the carburetor to the cylinder. When the piston moves down or intake stroke, then the four steps are repeated. Uh, as you can see at this picture, for the step 0 until 1 is the suction stroke or mixture of air and gasoline vapor enters the cylinder. For the step 1 until 2 are compression steps. A mixture of air and gasoline vapor is compressed adiabatically. For the line 2 until 3 are rapid combustion that result in heating the gas at the constant volume. A mixture of air and gasoline vapor is heated at the constant volume. The mixture is burned. For the step 3 until 4 is the hot gas expansion step. Burning gas undergoes adiabatic expansion. And for moderate segment 4 until 1 pressure drops suddenly due to the opening of the exhaust valve cooling at constant volume. The burned gases are discharged into the exhaust pipe and the new air plus gasoline vapor mixture enter the cylinder. And now is the diesel motorcycle. The diesel motorcycle is an air cycle at constant pressure. In general, the type of diesel engine is designed to meet the ideal diesel cycle, which is like the Otto cycle, but the heat input process is carried out at constant pressure. As you can see at the picture, for the first, the section stroke 0 until 1 is the constant pressure process. For the second, the compression stroke 1 until 2 is an isentropic process. For the third, the process of heating at constant pressure 2 until 3 is heat input process. Work step 3 until 4 is an isentropic process, and the exhaust step 4 until 1 is considered to be a process of removing heat at constant volume. And for the last, the exhaust stroke 1 until 0 is occurs at constant pressure. That's all from me. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.